So far, we've covered the most basics of data type in Python. Now, before we move on to basic Python built-in objects such as lists, tuples, and dictionaries, let's talk about providing some feedback to your users who run your code. You may have written the most complex algorithm in Python, or written the most beautiful code that there is you can write. But there's nothing worse than providing a badly formatted output or a nonsensical message to the user who's running your code. You could provide an output that says error, something went wrong. Well, we could figure that out when we read the error part. Or your output says answer is 5.012345, whatever, right? Well, what does that mean? Is that 5.0132 elephants and horses, or is it 5.0312 square miles? Or is it the area of the square? And even if it is the area of a square, then why do we need so many precision points? Why not just round it out to 5.0132 or 013? So let's talk about all of that. How do we print? How do we write proper output when it's required? So let's start our Python interactive terminal here. Python, and so far, whenever we've tried to print an answer or a message back, we've pretty much just said, printed the variable. For example, if I said x is ACTG, right? And if I say x, well, there's the answer. But that's not really anything informative, right? If your program outputted just ACTG, what does that even mean? And especially in writing a program, how would you print that? This is Python interactive. So if you write within the Python interactive, you say x, okay, you get the output of what the value of x is. But how would you do that in a program that you would run not interactively, but as a Python executable code? Now for that, we would use print statement, right? So you simply say print, and it's a statement, not a function. So at least in Python version 2, these are print statements and not print functions, and we'll go over the difference between 2 and 3, Python 2 and 3 in a minute. But in the print statement, you just say the keyword print and provide your string that you want to print. So print hello world, and it will print that. Or you can say print in double quotes hello world and get the same answer. And to give you an idea of why I like to use double quotes, I can say print hello world and single space something. Whoops, I forgot to close before I hit enter. If I close, hit enter, now you get single quotes printed, right? But if I were to do the same with single quote, and if I had a quote here, now this will produce an error because we had a starting quote here, and this is interpreted as an ending quote, and now we have something extra hanging out here. So that's why I prefer to use double quotes, especially for bioinformatics projects, since you could run into cases where you have single quotes embedded within your input string somewhere, and you want to kind of handle that case gracefully. So moving on, now these are just hard strings. What about variables? How did you print that? Can we say print and within quote the variable? Well, no. Anything that's within a quote is considered a literal string, and whatever is within the quotes will be printed as it is within that quote, right? Or I can say print double quote x single quote double quote, and it will print that single quote as an exclamation point. So in order to print variables, you would say print and just provide the variable name, and that would print you the variable that you chose to print, or an answer that you wanted to print out, right? In this case, our x is the variable ACTG, and so it prints out ACTG. And note that it prints without quotes, right? Everywhere, except there's a single quote in our string, so it printed that. Does not do something that Python Interactive does, where if you say X, it prints out the single quotes around your string. Now over here, I'm going to switch over to our Atom editor so we can get a better sense of what these print statements are actually doing. I mean, we can say X is equal to ACTG here, still being in Python editor, and if you say print X or print, you know, hello world, which is fine, but this is not exactly how you would see the output when you're working in a code and you execute your Python code. So let me switch over to Atom editor here and give you a quick look of how these print statements would work. So this is my Atom editor. I've opened a new file here, and I'm going to quickly click to this little bit here which says plain text, and I can barely read it. I'm not sure if you can, but trust me, it's there. If you have your Atom editor open, you should see it. If I click on that, should be able to type in Python to make sure that this file is interpreted, or any commands written here are interpreted as Python commands, and then we get all the help and syntax tools that we need. Okay, so let's duplicate our Python command line editor. I'm going to paste in some code here, which is same as we had before, where our X is defined. We said print hello world and print X. Now if you're on a Mac, you can say Command I to execute the script, or you can go to package scripts and say run script, and that will run the script for you. So as we run this, there it is, and you don't have to leave the Python or the Atom editor, so which is a great thing here. So once we print our hello world and print X, we get the output right here. So it says hello world and X. Right? So far so good. Now right now we printing a message here on one line, and then the output of the variable is on the other line. Now imagine if this goes on for quite on and on, right? Your output is pretty large for a screen. If that happens, how would you distinguish between what is the message and what is the output that belong to the message? That gets kind of hard to decipher once this output window gets large. So wouldn't it be nice that if we can print the value of our variable along with the message all in the same line, right? So let's do that. Let's remove this, and we're going to say some work done and DNA string now is, and I want to print X. How would we do that? If I just say X within the quote, well, that becomes a literal string, right? As we've seen before, if I do that, it became a literal string. It says some work done here, and X was printed as is, as a literal string. But I don't want X, I want the value of X here. So in that case, we would use something called as placeholders. In this case, we would say %s. So here's a placeholder, and there are different type of placeholders available for us to use. %s is for string. There's for floating point, there's %f, and for integers, I believe is %i. So we'll say %s as a placeholder, and then we want to interpret or evaluate the value of X first, and then place that into this placeholder. And we do that by saying %parentheses X around. So if we run this now, let's remove this guy here. Right. If we run this, sure enough, we say some work done, and then the value of X has been evaluated and placed into the placeholder here. Now this placeholder does not need to be at the very end of the string. It could be anywhere. If you put it here somewhere in the middle, this doesn't make sense, but just for purpose of display or demo, there it is. Wherever the placeholder is in the string, so in this case it's in the middle, or in the front or the end, the value gets evaluated and placed where that placeholder is available in the string. So let's move this back to the end. and run this one more time, right? Okay. So here we're saying that this placeholder %s, and what it's telling the print statement to do is take anything or transform anything that's within this parentheses and transform that into a string and place it in our placeholder, right? So that means anything will be transformed into a string, which means numbers, floating point values, or integer. So if I replace x to say 10.5 here, and if I run this, that still works. That's still a valid statement because 10.5 can be evaluated to a string. But if I just put this as 10.5 here, which would equate to the same thing, and if I run that, that gives you the same answer, right? So you can convert strings to numbers. I meant you can convert numbers to string by providing quotes around it, and you can do the same for whole numbers or integer values, and it still gives you the same answer. Now, what if our output variable is a large floating point number? Let's just say call it pi 3.1415926, right? We change this to pi. This will surely work. We transform the value of pi into a string and then place it into our output stream. So if I run this, that works, right? Our work done, and the value is 3.146. Now, this is great, but what if we want to format the number? What if we want to have it only print up to 2 decimal points or up to 3 decimal points? How do we do that? Well, for that, we can use the %f, which is for floating point place values, and then we can format it from there on. So we can say %f. I should write in a different line here, just to give you a better look at this. So %f, we're going to say this, whoops, and then we're going to format this by saying .2f, right? Bear with me here. So if I run this, there it is. So we're saying transform whatever this value is here into a floating point number, and then up to 2 decimal points are taken and everything else is discarded. So that's exactly what happened here. If I change this to 3, that will make it 3 decimal points, right? Or 4. That makes it to 4 decimal points. And you get the idea. Now we know that if we say 0.3, that will transform the number to up to 3 decimal points, right? And it will round up or round down based on what the value is. But we could similarly write a number to the left of the decimal point. In this case, it will have slightly different meaning. It means that this number right here indicates that the total minimal length of the number that should be outputted, right? It's important to know it's the total minimal length. That also includes your decimal points. So if we said 5.3, right, for x, or let's just say, let's say 5.3 for x. And for our pi, we're just going to write the same format. So what are we saying here is we want minimum of 5 digits in our output, and 3 of those should be decimal points. So what if we run this? If we run that, right? So our x was actually just 1.1. By saying it's 5.3, what we're saying is we want minimum of 5 digits. So now it's 1, 2, 3, 4, and period counts as well, or decimal point counts in that length. So that's total length of this is 5, and 3 of those is decimal points. So there it is. And similarly for pi, it gets 3.142. Now, if we provide a large enough number here, what if I just call this 10, right? If I provide a large enough number and run this, what would happen is if the number is less than that value, and note that this means our minimum output should be of 10 digits long, right? And if anything, if our number that we're printing is less than that, then it just gets padded with spaces in front of it, right, as you see here. And by default, if our precision point is not up to 3 decimal points, then the number gets padded by zeros. after the last value that's available. In either case, this doesn't change the value of the number, it just makes it look a little pretty. So the general form of our format string looks something like this, right? Where we have a key name, a flag, width, precision, and type code. So the key name is the name of the key to be indexed in a dictionary. When we go over dictionary, that will become more clear. The flag has actually three components to it. It's meant for left justification. There's a plus sign or a minus sign to indicate whether a number is positive or negative. The type of fill that you want, whether you want to fill the left justification by spaces or some other character, or 0, for example. Your width indicates the total width of the output, right? So total number, including the fill on the left, the justification on the left, the number itself, the decimal point, and the precision values. And the precision just means but how many decimal points you want your number to be precise to. And then your type code, which is S for string, you have F for floating points, and you have I for integers as well. So a quick example what that flag value might look like. So let's just say print value of X is, we're going to say percent. I'm going to ignore the key name for now. Let's say we provide a positive or plus sign to indicate a positive number. I'm going to say 010.3f, right? And I'm going to say percent, X. So what does that look like? Right? So we're saying minimum of 10 is our output length, plus to indicate if it's a positive number, and then we're going to fill with zeros instead of spaces. Over here these are spaces, and they became zeros here, and up to 3 precision points. So if you count this, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the plus or minus sign became the 10th value, right? So the important thing to remember that the number directly to the left of the decimal point is the total length of your output. That includes your flags and any padding or spacing to the left of it.